Edit distance can also be weighted. Why would we add weights to the computation of edit distance? Think about particular applications. In spell correction, it's obvious that some letters are more likely to be mistyped than others, while in biology, because of the constraints of the subject matter, some kinds of deletions or insertions are more likely than others. So for example, in spelling, here's a confusion matrix for spelling errors. So if you look at this confusion matrix, you can see that E is very likely to be confused with A, or O and E. So vowels tend to be confused, but it's very unlikely to confuse A and B. So A's are confused with E's and I's and O's and U's and so on. So they're the kind of spelling errors people make have systematicity to them. So not just confusing vowels with vowels, but also the fact of the keyboard means that you're likely to make errors either using the homologous finger on the other hand or using nearby keystrokes. So the constraints of the domain, in this case we're talking about spelling, or maybe we're talking about biology, are going to make some edits more likely than others. So we're going to represent this by modifying the algorithm slightly to add weights. So where in Levenshtein distance we had a cost of 1 for insertion, 1 for deletion, and 2 for substitution, in weighted minimum edit distance we simply add a special cost that we have to look up. So the initialization, instead of adding 1 for each deletion, we have the actual cost of deletion. And instead of adding 1 for each insertion, we add the cost of each insertion. And so on for the in the recurrence relation, we're going to add a special cost, delete of x sub I. How much does it cost to delete that particular character? How much does it cost to insert that character? How much does it cost to substitute that character? And we're going to end up with the termination condition. So we're just going to add separate little tables, lookup tables, that will tell us what the deletion, insertion, and substitution costs are. By the way, where did the name dynamic programming come from? Here's some quotes from Richard Bellman's autobiography. Bellman was the one who invented dynamic programming, and amusingly, he tells us that he came up with the name for dynamic programming really as a public relations move to make an algorithm sound exciting. So this is maybe one of the first algorithms that was named in a branding way to make an algorithm sound exciting. So there's our, in sum, our algorithm for weighted minimum edit distance.